Okay, let's do a problem together. Getting to the wide world of screencasting things and showing you how to do stuff. So, here's the problem. Vang has got a 6-inch ratchet, quarter 20 UNC screw. We need to figure out what is the ideal mechanical advantage of the ratchet and screw. Well, first of all, we know that ideal mechanical advantage is equal to the distance of the effort divided by the distance of the load. It doesn't matter which simple machine we're using, it's always going to be that. Okay, the problem with the screw questions is that you're not able to easily see what the distance of the effort and the distance of the load are. So Vang has this ratchet, this should really be a socket wrench or something, but whatever it is, he's going to take this and turn it in a circle like that, and it's going to look better than that. But what can I do? I can only draw so well. He's going to take this, spins it around. He has done one revolution, okay? And that is a certain distance. And some of you are saying, well, of course, that's a certain distance. We know that that is going to be 2 pi r because it's a circle, right? He turns it in a circle around an axis, and he gets a distance of 2 pi r. So for this problem, the r is going to be equal to the length of the wrench, 6 inches, because you're going to get 6 inches on this side, and then on the other side, you'll have, it's going to spin all the way around it on that side too. So this whole thing, the whole diameter would be 12 inches of this circle, but the radius is 6 inches. So then we use the 2 pi r, and would be 2 pi times 6, right? Because 6 inches is the length. So 2 pi times 6 will give us 12 pi. And now this, of course, is going to be the distance of the effort, because this is where Vang is going to put his hands and where he's going to turn. Okay, remember, distance of effort is where you put your effort, okay, where the human effort is applied. So in the distance of the effort, we'd say 12 pi, and then the units are inches here, so it'd be 12 pi inches. We'll clean this up and make this a decimal answer a little bit later. Distance of the load's a little more complicated. This is a screw, okay? And a screw looks like this. It's a very crude drawing of a screw, okay? And in a screw, there are all these different threads, okay? And the threads are an equal distance apart. And this 20 here means that there are, in this screw, 20 threads per inch. Okay? What that means is if you were to go and spin this thing 20 times, you would go 1 inch equals 20 spins. Okay? Or 20 turns. But Fang's not spinning this 20 times. He's not turning it 20 times. He's turning it once. So he can only go 1 out of the 20 turns. So this is a distance every turn of 1 out of 20 inches, or 1/20th of an inch. Another way to write that using a decimal would be 0.05 inches. Okay? This is how far the screw is going to move every turn. Okay? 0.05 inches. So we would say the distance of the load then is 0.05 inches. Okay? We have distance of effort, we have distance of load, and we have our equation right here, right? So let's put that in there. We'll change colors for when we do the actual problem. So IMA is equal to the distance of the effort, as I said, over the distance of the load. Another way of writing that with inputting our numbers would be IMA is equal to 12 pi inches over 0.05 inches. Okay, now 12 pi is kind of unwieldy, so we'll turn it into a decimal. We'll multiply by 3.14 because that's about pi, and we'll get 37.68 inches over 0.05 inches. That's going to give us our mechanical advantage. So we take 37.68 divided by 0.05, we should get a big number, and we do. That's going to equal 753 13.6. That is our ideal mechanical advantage of this screw and wrench system, or ratchet and screw system. Okay? Now, that looks great. A screw and ratchet is always going to have a high mechanical advantage. This number under here is always going to be less than 1. Okay, I wanted you to put that in your brain right now. This number under here is always going to be smaller than 1. Okay, it's going to be between 0 and 0.99, but really it probably won't get any smaller than 0.125, maybe 0.25, but it's always going to be a very small number underneath here. Okay, so 753.6 is our IMA. Now it says if Vang measures the force he uses to turn the screw at 18 newtons, what is the load force of the screw? Assume no friction. So assuming no friction means IMA equals AMA. Okay? So the force that Vang uses is 18 newtons. So that's going to go in our force of effort. Okay? We have an equation, AMA equals force of load over force of effort. Okay? Our AMA, for the purposes of this problem, our AMA and our IMA are the same, so we'll say 753.6 equals force of load, which we don't know, over force of effort, which is 18 newtons. Okay, we want to isolate the variable, so in order to do that, we multiply both sides by 18 newtons. This gets canceled, so we take 753.6 times 18, and it gives us a big number, 13,564.8 newtons. Okay, 13,564.8 newtons. That is our force of load. Okay, all right.